Hey, this is Alex from Gretel. Today I'm going to walk through a notebook using Gretel GPT to create differentially private synthetic text by fine-tuning a large language model. In this case, we're going to fine-tune the Mistral 7 billion parameter instruct model on a sensitive dataset, and then we'll use it to create private text that is safe for AI ML training without any worries of privacy or identification. So let's jump right in. We'll start here. We'll install the Gretel client, also the Hugging Face datasets dataset. We're going to be working with a set of dialogues from the Common Sense dialogue corpus. First thing we'll do here is set up our project. We're going to name the project DP Synthetic Text, and you need an API key from Gretel to log in. So you can see I've already done that. Next step here is we'll load up the dataset. I did some slight formatting of the dataset, so I just went ahead and hosted it separately on Hugging Face, but we'll load it up into a data frame format and take a look at the first result here. So we can see in the sample dialog here, you see it's starting off with this kind of common context for what the conversation is going to look like. And then we see actual like a type of step-to-step dialogue that you would have in a conversation. And then a little bit of stats about the data set. So pretty small, about 9,000 rows that we're working with, about 5 megs on disk. Next thing we're going to do is train Gretel GPT. We're going to use differential privacy. So essentially what that does is it inserts noise and targeted noise into the optimizer as the model's training, and has the effect of providing guarantees that no record in that data can be linked to any individuals the data is based on. So we'll create synthetic data that looks just like that original data, but it cannot be attributed to any of the user entities that the data set was based on. So we'll take a look at that. We'll see what that looks like here in a minute as well. Here's the basic configuration. We're starting with the base YAML configuration, which you can check out on the link above. We're going to make some modifications here, really hyperparameter tuning a little bit just for the best results possible. The important area here is that we're turning on differential privacy. So on the privacy params, you can see DP is set to true. We're using an epsilon of 8, which is a very strong guarantee. This is actually typically stronger than the guarantees that Google or Apple use in their implementations. So a good high level of privacy we're going to get here. The lower the epsilon, the higher the privacy, but also the more of the impact you have on utility. So you want to find that right balance to work with. We're going to generate 100 records, and we'll use that to create a synthetic quality score report of how good of a job did the model do at learning and recreating the distributions of the data it was trained on. So we're submitting the GPT training job. Fine-tuning in this case takes about 2 hours. You can follow along if you would like, either in the docs or on the console URL, so you can watch this kind of happen in the Gretel cloud as it's being trained. We'll stay in the notebook for now. We can see it's using PEFT, differential privacy for training. Once training is complete, you can then start sampling from the model and looking at the quality results yourself. So we can see it had a final epsilon of 7.96, which is quite strong. If you want to reload the model later, you can use the model ID and the Gretel SDK to load it right up. We'll take a look at the synthetic quality score report, and then we'll view a sample generation. So from the 100 records that we sampled from the model at the beginning, what did a sample generation look like? You can see this also looks quite like the input text, so it looks like it did a good job. We can see here, particularly in the semantic similarity here, the text semantics, the details inside of the text, is quite good. The structure, which is what that's looking at, like how many words per sentence, how long were the words in each sentence, things like that, were a little bit different than the original data. So it might be something to look at. Just eyeballing it here, this looks very good and kind of on topic. Going a step further, so yeah, long way of saying that I would weight heavily on the semantic similarity here, which it did a great job at learning. This structure similarity is very use case dependent. Sometimes it matters you perfectly recreate the structure. Sometimes having a little bit less sentences or a slight deviation from the input format isn't a big deal. Now that we have our fine-tuned model, what are we going to do with it? First thing most people want to do is prompt the model to generate text for them. So we are going to load up the model in a batch mode here and prompt it with a series of 5 example conversations. So here we see, starting off just like the input data did, the context of the following conversation. So we're going to our pre-trained model. We are adding some context in here that someone's at a dinner party at a high-end restaurant and they spilled soup on the host's expensive rug. So we'll submit this job to Gretel. Essentially, it's going to be completing each one of these 5 prompts with a dialogue similar to what it was trained to do. The job gets submitted here. We have some typical LLM training parameters or inference parameters. And then the results come back, and we'll look at the first example dialog here. So the sample dialog looks quite good. So in reference to spilling soup on the rug, she apologized, and I paid for the rug. And then you have the rest of the content as well. So here we're looking at differentially private synthetic text that's been generated using the Gretel GPT service on top of the Mistral 7 billion parameter model. Exciting stuff. If you want to dive in and look at the model itself or follow along on the console, you can even use that to generate more data. Just click the console URL. It'll take you right here. You can see the example input data and the example outputs. You can see the score and a really nice high quality version of the synthetic text quality report. So here we load this up. We can see a much more detailed analysis of the scores than the preview that we looked at earlier. Here's the semantic similarity, looks quite good. So we've got a 91 there. And then on the text structure, you can see some of these things like the words per sentence in synthetic text were slightly less than was in the original input data. You can fix that often with inference parameters. And then a few less characters per word in the synthetic text than what we're seeing in the real world data. But once again, very close. This would be a good data set to work with. Thank you.